All right, here's a question. A car travels between two sets of traffic lights. Okay. The diagram represents the velocity time graph of the car. Let's highlight that. Okay, this is a velocity time graph of the car. If you notice, you've got velocity on the y-axis labeled, and you've got time on the x-axis labeled. Now, you might be wondering, well, yeah, it's obvious. It's just because later on we're going to deal with things like acceleration, and you're going to start to see those labels changed. Okay, that's why I'm making it obvious right now. Right, let's start off with some of what you guys might know. Who can tell me what is velocity? What does that mean? What does velocity mean? Who can tell me that? Excellent, very good. Velocity is a speed, a measurement of speed, but with the direction. Okay, so there's something we all know, which is speed, and then we have velocity. And the difference between the two is speed is just a unit, a magnitude. Okay, so I could say to you that something is traveling at 45 miles per hour. That's just telling you the magnitude. I'm not telling you which direction it's going at 45 miles per hour. Whereas with a velocity, I would say to you that something is traveling 45 miles per hour due east. Okay, due east. So it means that it's going that way, 45 miles per hour. Whereas this one, the speed, it could be going that way, it could be going up, it could be going down, it could be going east as well. Okay, it could be going diagonal too. All right, I don't know. Now, all these terminologies, guys, you most likely you don't have to memorize them, know what they are. You just need to know how to deal with them. All right, how to deal with velocity and speed. All right, all right. Let's go. Let's go and answer this question now. So, this car is leaving the first set of traffic lights and it's going to the next set because there's two sets of traffic lights. Okay, so this is the first set of traffic light and this is the second set of traffic light. Okay, and it traveled. This is showing the car's travel to that second set of traffic light. So let's see what's going on here. So the graph here, it goes up and then it bends a little bit. What does this mean? Who can tell me what that means? What does that represent? Very, very good. It's an acceleration. My question to you, is it a constant acceleration? Very good. A constant acceleration has a straight line. These are notes you need to write down. Okay, you should be writing notes like this. Okay, a constant acceleration is a straight line. Can you see on the other side? It's constant. It's a straight line coming down. All right, whereas this one, it bends. Okay, that means it started off constant, right? And then it started bending. Maybe it's reached. So I can describe this to you. What's going on is the car sped off from the traffic light, and then it started to ease off the gas until it reached the desired speed of 12. Maybe that's the speed limit. Okay, 12 meters per second was the speed limit. So it continued going at 12 meters per second. And then what happens? What happens here? Do you know what we call that? When something decreases in speed? Very good. So this is the opposite of acceleration. It's a deceleration. That's a constant deceleration. So why is it doing that then? Who can tell me why is it starting to decelerate here? Very good. That's exactly why, because it's seen the traffic light from a distance at 50 seconds, and it takes 10 seconds to slow the car down. And what happens right here? Very good. It stops. It's stationary. I want you to learn a new word now and use that in your vocab. It's stationary. Stationary means not moving. The velocity is zero. And as you can see here, if you go across to the y-axis, the velocity is zero at that point. So the velocity was zero here, and the velocity was zero here. Of course, a car is not moving at a traffic light because it's waiting. Now, the first question is, use the graph to find the velocity of the car after 15 seconds. Nice and easy. We can just read that from the question. You go and find where 15 is on the x-axis, where the time is, and then you draw a line, you see where it hits the line, and then you just simply read across. Okay, you just go across like that. Okay, that's what you'll do. So I'm going to zoom in here so you can actually see it a bit more clearly. There, go across, boom, there you go. So what value is that then? That's another problem. Now you have to work out what the value is. How would I work out that value? Who can tell me? How would I work out what value this is? Given that this is 10, this is 12, that means the jump here is obviously 2, So how would I work out the value? What is each of these squares worth? How would I calculate that? Very good. So I see the difference. The difference here is 2, right? So the difference here is 2. And I know that there are 5 boxes in between. So I do 2 divided by 5. If I do 2 divided by 5, that's 0.4. So each of these squares is 0.4. So therefore, if you go count now from 10, so 10, what's this? 10.4, 10.8, 11.2, and that is 11.4. 11.6, sorry. 11.6. I'm sure some of you are sitting there thinking, no, it's supposed to be 11.6. Okay. Is that right? Question says, calculate an estimate. And this is a very important word, an estimate. So what does that mean? Again, you'll have a range, okay? You'll have a range of values you're allowed. There is no one particular absolute answer. It'll give you a range because it's an estimation, okay? Calculate an estimate for the acceleration of the car after 10 seconds. Would you have found 10 seconds? Find 10 seconds right here, go up and read it. There. Would you have done that? Do you know why I made you say that? Because I want to show you something beneficial from that. Okay. Let's say we do that, yeah? So let's say we go up. Let's just hit it here somewhere, yeah? What is that value here? 9.6, yeah? So what do you now do with your 9.6? You're going to come here and you're going to write 9.6, correct? You're going to write 9.6. And then what's the unit going to be? Meters per second, because that's what you've read. And now you've seen that acceleration isn't measured in meters per second, so therefore you know that's wrong. That is not the correct thing to do, all right? So I had to show you that to sort of combat a classic mistake some students might make. You may have seen this before. What is the formula for acceleration? Well, we can use, we don't need this, but this is extra information. I'm teaching you extra stuff, so don't worry. You don't need to know this, yeah? Well, you might actually, but we'll see. Not for this, yeah? Velocity is equal to u plus at. Okay, that's what velocity is. A here, you're going to do this in mechanics when you probably do it in physics already, actually. What does u mean? Let's start with that. U means initial speed, initial velocity. That is 0 here, okay? So this is 0 here. That's 0 anyway, okay? So you end up having v is equal to a times t. And then if you want to make a the subject, what is it that you do? A is equal to velocity divided by time, okay? Velocity divided by time. So to find the acceleration, you need to do velocity divided by time. So how do we do that? What is that? That is showing us that velocity divided by time is actually the measurement of gradient, the rate of change of speed. That is what acceleration means, okay? Acceleration means, I know I'm getting very technical, all right? Acceleration means rate of change in, no, I shouldn't say speed, I should say velocity, in velocity, okay? So the rate at which the velocity is either increasing or decreasing. That is what acceleration means. And of course, when you look at this graph, this is not constant, okay? This is constant. This one will just do velocity divided by the time, okay? So it's gone from 12 all the way down to 0. We divide it by the time, which is 10 seconds. So we'll just do 12 divided by 10. That will give us the deceleration straight away. But when it's curved, we can't do that. When it's curved, we've got to do what I said, which is to go to 10. I'm going to zoom in now, okay? And we draw a tangent line, okay, at 10. So at 10 seconds, we go to 10 right here, okay? And we draw a tangent line, okay? So we get our ruler and we draw a tangent line. Now, what is a tangent? A tangent means that it must touch that point only once. It can't, this is not a tangent. It cuts the graph twice. It must touch only once. Let's do it from this side. It's probably easier to look at it. There. That's a nice tangent. Now, you might say, well, how do I know how much curved, slope to give my tangent? It's just an estimation. That's why it's called an estimation. So some students might do it like this. Some students might do it like that. Can you see it's a little bit off? We're going to be finding the gradient at that point or after we draw that line. That's what we're going to be doing. We're trying to create The aim is we're going to create a triangle here like this one. Okay, so we can do what we need to do. Okay, the rating change. So I'm just going to estimate a good tangent for myself. Tell me if you're happy with it. That's all I want from you. Are you happy with me drawing a tangent like that, guys? I don't want to just do it and say this is a tangent. I'm trying to show you that, look, you're going to have, you're going to think about this and you're going to think, am I doing it right? Am I doing it right? It's okay. That's the tangent. Okay, so I'm going to draw this now. There we go. There is my tangent. Can you see? Now, do you remember when I said to you, we find the difference here and divide it by the difference there, because finding the difference here is basically the velocity. Finding the difference here is basically the time. So once you know the value of that, you divide it by the value of the time, you found the deceleration in that case, but here you're going to find acceleration. So what I want to do now is I want to find good points and some nice corners that I can close up and make a right angle triangle. Now, if you look at it, there's actually not many good places I can do this on, right? There's nothing on the corners of these big boxes, yeah, to make life a little bit easy. But we have to do our best still. So I'm going to choose, and you can choose anywhere. It can be this triangle like that. It can be a bigger triangle like that. You know, you choose, yeah? So I like this point here. That's a nice point right there. I like that one. Yeah, I'm going to put a little dot here. It's going to be part of my triangle. And, oh, God. Nothing. Oh, yeah, this one's nice right there. Can you see that one? Yeah, that's all right. What do you reckon? I could have gone to for others as well. I mean, there's plenty I've missed out. Like here, that's all right. No, that's all right. But that you might look at that and think, oh, that's a little bit close to the point that we're looking at. So that's why I might not actually choose that actually on second thought. All right. But this one's all right. Look, right there. Yeah. You want a nice sort of distance away from your point. Okay, there we go. I'm gonna do it there. Okay, guys. So dot, let's just draw a little triangle now. It's probably gonna interlap. There you go with that one. And that is my triangle that I'm looking at right now. Okay, it's a right angle triangle. It's a right angle triangle right there. I'm going to find the difference here and the difference here. I'm going to divide that. All right. So let's look at the difference. What is this? 12.8. Yeah. 12.8. That's 12.8. And what is this? Oops, sorry. So that's 12.8. What is this? That's 5.6. Yeah. Okay, what's the difference? 12.8, take away 5.6, please. 12.8, take away 5.6. What's the difference? 7.2, correct? Right, brilliant. That's 7.2. Can you guys work this one out for me now? What that is? So that is what? What's that? 4. And what's the other side? 15. What's the distance there? 11. Okay, so if you go out now and we want acceleration, the velocity is 7.2. The distance here, that's all. Okay, I can give you the proper formula for this, by the way. There's another formula for this. You're probably going to appreciate. I mean, I don't want to give you too much information overload, but you are, listen, you're top guys, yeah? You're grade 9. You should actually see it. There's another formula that we use, V minus U over T, okay? So V means the final velocity. U means the initial velocity. We do the final velocity, take away the initial velocity. So look, when we mark this point here and here, this was initial velocity. This was the final velocity. So we're doing V minus the U, and that's where we get that 7.2 from. Can you see? And the time here is just 11 seconds. All right, so we divided by 11, the time. All right, that's how that works. And this is what we're practically doing here. So 7.2 is as a result of V minus U, divided by the 11. So we get our calculator now, and we just do 7.2 divided by 11, and the answer to that is 0.65. There you go, meters per second squared. That's it. Now, I did this question earlier, and I got 0.64 because I used different tangent, slightly different, but can you see, it would be around 0.6 something. All right, even if you write 0.7, you probably get it. 0.55, you probably get it. All right, so I'm going to zoom out now, absorb that. Ask me any questions that you have. Look at what we did. It's that graph. Lots of work has been done on that graph. So question time now. Is there anything that you didn't understand that you want me to go over before I move on to the next question?